Welcome everyone, and thank you for joining us for this panel, which is part of the MTalks event that we are hosting this afternoon at the MPavillion in Melbourne. Today we are joined by an audience on site in Melbourne's CBD, as well as an audience watching this panel online as a webinar. My name is Hussein Dian, and I am Professor of Future Urban Mobility and Deputy Director of Swinburne's Smart Cities Research Institute. It is my pleasure to be with you today to moderate this panel on the promise of hydrogen in transport, where we will explore with our expert panel the hydrogen landscape and tackle some hot questions, if you like, on the future of hydrogen in transport. Before we start, and on behalf of those present, I would like to acknowledge the traditional custodians of the land on which we meet today and pay my respects to their elders, past, present, and emerging, and hope that the path towards reconciliation continues to be shared and embraced. Now to our panel. To help us navigate the complexities of the hydrogen landscape and differentiate hype from reality, I am delighted to welcome our panel of experts who bring wide-ranging perspectives on the topic through their own extensive research on energy transition. Joining us from New Zealand is Susan Krumgier, a professor and chair in energy transition engineering at Heriot-Watt University in Scotland. Susan is currently in Christchurch, where she is also an adjunct professor at the University of Canterbury. Susan is author and thought leader in energy transition engineering, specializing in developing solutions for decarbonizing transport systems. Joining us from Brisbane is Robin Smith, Director, Transport, Energy and Emissions Research, and adjunct associate professor at University of Technology, Sydney. Robin is a transport emissions modeling specialist, and his research has been influential in developing emissions models that are today widely used for facilitating the move towards clean and zero emissions transport. Joining us from Paris is Elizabeth Conley, Energy Technology and Transport Analyst at the International Energy Agency. Elizabeth is an award-winning researcher with interests in sustainability topics, particularly transportation and energy policy. Her recent work is focused on hydrogen energy research, and she previously worked as a researcher at the US Department of Energy H2 Technology Office in Washington, DC. And joining us from New York is Justin Mikonka, investigative journalist for the independent news and research organization DSMARC. Justin is member of the Society of Environmental Journalists. His research covers the finances of energy transition and the cost effectiveness of transition technologies and the potential of hydrogen as a climate saving solution. So welcome to you all. I know it is very early for you in Paris, Elizabeth, and also very late for you, Justin, in New York. Thank you for making the time at unusual hours of the day. I would like to start by setting the scene for some questions to guide our discussions today, and I will then invite each member of the panel to spend 5 minutes to provide their own perspectives, and then we will open it for questions from the audience. For those joining us online, please feel free to drop your questions in the chat box at any time. So if we look back at developments over the past 20 years, we find that hydrogen and fuel cell technologies have seen cycles of high expectations, followed by some disappointing and impractical realities. Back in the early 2000s, hydrogen vehicles were predicted to drive the hydrogen economy use cases and was forecast to become the dominant mode in the clean automobile market. However, the promised hydrogen highway never happened. Hydrogen power needed new infrastructure, whereas rival battery vehicles could be charged using existing electricity grids. High-powered batteries at the time were already well advanced for other use cases, such as in computers, but hydrogen research was still lagging behind. But we have seen recently a renewed global interest in the hydrogen economy. While some of this interest has been driven by concerns over climate change and the need to move away from fossil fuels, some of the fundamental concerns and questions about the efficiency and cost effectiveness of hydrogen in transport applications still remain. Some of the questions I would like to pose to the panel. Is hydrogen really the lifeblood of a zero carbon road transport future? Or is it a hyped distraction from more effective transport electrification solutions? Can hydrogen fuel cell vehicles compete with electric vehicles? Has enough attention been given to the technology's potential environmental challenges? And finally, as governments around the world start to commit investments in hydrogen research and applications, how do we avoid the risk of supporting an expensive and energy-intensive technology where better solutions are available? I would like to begin with Susan. Susan, you have been researching this topic for some time now, and you recently published a new book on transition engineering, where you examine different strategies to tackle global climate change. What does your research tell us about the prospects of hydrogen in transport?
All right, well, those are really good questions you've posed. It seems like it's really difficult to move forward, whether you're advocating for hydrogen or not, or just trying to figure out what to do. And that's where transition engineering comes in. So transition engineering says, okay, look, in real places, with real people, with real money, doing real things, projects have to be initiated, carried out, procured, validated, consented, and done. That's the way things work. So let's go to that level. Let's go to the ground up. So we're going to put away for a minute the top-down COP21, what the grid might do, what things that are outside our control. We're going to go to our own city. And then we are going to ask the question, okay, what are you supposed to actually do? We know why we travel around our city. It's to engage in activities. We know how we do it today, and we know that has to change. So I'm going to show you how a simple little engineering project goes here, an analysis. Because what we want to do is we don't want to spend any time on things that nobody's going to pay us to do. We want to get right to what would be promising. So I'm going to show you a slide because we're going to go to Christchurch, New Zealand, a real place. With real people. There's 380,000 people. There's 300,000 cars. We like our cars. And we chew through 8,000 tons of petrol and 100,000 tons of diesel a year in our little city. All right. Our business as usual is that we all drive about 12,000 kilometers a year, which is 33 kilometers a day. And off we go. All right. So that's our business as usual. What we do is we develop scenario concepts for what we could do, and then we put the numbers to them and evaluate which one looks like a good deal. All right. And all of those are compared to the business as usual. So the concepts are, okay, our mission is to reduce emissions in Christchurch by 30%. Well, if we substituted hydrogen vehicles using our 100% renewable South Island or wind electricity, that would do the trick. So that's option one. Option two, substitute with EVs. Obviously the same thing. We've got renewable electricity. So quite easy here. It's kind of cheating, isn't it? Then we had two more concepts that we arrived at by a process that we call interdisciplinary transition, engineering, innovation, management, and it's trying to make you think outside the box. And it worked because we said, well, okay, here's a scenario where we have 100,000 e-bikes and we build 100 kilometers of electric tram throughout our city. We laid that out, saw how it would work. And then the final scenario is we just don't use so much oil. We use 30% less oil. We don't change anything. We just use 30% less oil. Oh, that's weird. Have you thought of that? So now let's see how the evaluations come out. There's the evaluations. What you do is you calculate how much it would cost. So infrastructure cost, consumer cost, societal effects, like does it cut anybody out of the system? Do people lose access to activities? And that has to be done by analysis of travel demand and geospatial analysis. And then what's the effect on the environment? And you can see the business as usual, since it's all petrol and diesel, that gets a very low score. A low score is 0. The highest score you can get is 5. Then the materials that are used in order to do that system, everything comes with a price. So what's the material footprint? What's the life cycle cost assessment? And then health and safety aspects. One of the most dangerous things, actually the most dangerous thing in our city right now, if we're not having an earthquake or a massacre or a pandemic, is our cars. Our whole car system is a dangerous place for cyclists, for kids, everybody. All right, so we do all these calculations, we put all the scores in, and we get the final tally of where we would look. And what we see is that we don't really gain much in going to EVs. We definitely get reduced emissions, but other than that, there's a lot more material use. So it's about on a par. But look at the other two scenarios, the two concepts that we came up with by using transition engineering methodologies. We get huge benefits. 30% fewer cars on the road. We get these big safety boosts from that. We get, a lot more uses of spaces. And look at the amount of electricity we'd have to generate for each one of these ones. I think this is really important for this discussion, to run 30% of our vehicles, which would be 100,000 Toyota Mirais. That's what's available. They aren't available, in fact, because they don't make them. They make all up, there's maybe 10,000 on the planet. So something new would have to happen. They're very expensive. We'd have to build the hydrogen infrastructure, and we'd have to build several wind farms in order to power that. With the electric vehicles, we definitely have to build some more generation and transmission. And this is going to be tricky. And with e-cycles, we have to charge those e-cycles, but I think you're seeing the orders of magnitude difference here to run the tram and the e-cycles. And if we don't do anything except not use as much petrol and diesel, our research has actually shown that is a distinct possibility. No spend, no more electricity, just adapt to using less fossil fuel. And in Christchurch, the measurement of that adaptive capacity is 40%. So we could meet this without any expense, but it would take some novel ideas and novel technologies of how you would actually get that. So that's where I want to leave you, because that is fun stuff, innovating.
Very good. Thank you, Susan. And we will be coming back with some follow-up questions around these. But second, I would like to move to Robin. And Robin, you have been doing some work in this space as well. Similarly, what do you think? Is it hope or is it hype?
Yeah, I'm a bit skeptical about hydrogen, and I will outline why. So I can just go through my my presentation in 5 minutes, and we can have a discussion later. So I'm coming from a top-down approach, really, compared to Susan. So I'm looking at climate change. So according to the Paris Agreement, the world needs to achieve at least a 50% greenhouse gas emission reduction by 2030. This is needed to limit the rise in global temperatures below 1.5 degrees and prevent potential runaway climate change. And 2030 is only 10 years away. Currently, global road transport is burning 2 Olympic-sized swimming pools filled with fossil fuels per minute. So clearly, this is a massive amount of greenhouse gas released in the atmosphere. So I'm looking at hydrogen as a transport fuel from a climate change perspective. The question for me is, does hydrogen offer a solution in terms of the needed rapid reduction in greenhouse emissions? I think first of all, it's important to clarify what type of hydrogen we're talking about. Currently, hydrogen is produced with fossil fuels like natural gas and coal. This is called gray hydrogen, and it's already a significant source of greenhouse gas emissions. Hydrogen production reportedly accounts for about 2% of global man-made greenhouse gas emissions at this stage. Several studies have shown that hydrogen needs to be created with renewable energy like solar, wind, and hydro to achieve a significant reduction in greenhouse gas emissions. This is called hydrogen, green hydrogen. So it uses electrolysis to convert water into hydrogen. And hydrogen is clean only if it is produced from renewable sources of energy. My company, Transport Energy Emission Research, published a report in December last year, and we looked at the entire life cycle emissions of electric vehicles. So not only operation, but also production of vehicles and disposal. And compared electric vehicles with fossil fueled vehicles in the Australian fleet, focused on passenger vehicles. The study explicitly accounted for uncertainty in all the different inputs and concluded that battery electric vehicles already reduce greenhouse gas emissions per kilometer by 30% in Australia, which is still largely fossil fueled, and will provide deep reductions of about 75% with more renewables. So accounting for uncertainties, electric vehicles are a clear winner. But what about hydrogen vehicles? I think hydrogen vehicles have a fundamental challenge with energy efficiency. This means that the amount of energy or renewable energy required to drive a hydrogen vehicle 1 kilometer, for that same amount of energy, you can drive 3 electric vehicles the same distance. I think this is a very important point. In my view, energy efficiency is an overlooked aspect in the hydrogen debate, and it needs to be brought into the light. I think it's a key consideration to reduce greenhouse gas emissions rapidly. I don't think we can afford to throw away a big chunk of available energy and turn it into hydrogen for transport. So I have to conclude, from a greenhouse gas reduction perspective, really electrify transport where you can and use other options like green hydrogen where you can't. And one of those options often mentioned is shipping. So similar to road transport, battery-powered ships represent the most energy efficient technology. However, the low energy density of batteries limits the potential of fully electric ships for long distance journeys. So electric ships can be highly effective at reducing ship emissions for short distances, let's say less than 200 kilometers. And indeed, electric ships like ferries and tugboats are already deployed around the world. There are reportedly approximately 250 battery electric or hybrid vessels, either currently operating or on order globally. The information I've seen suggests that hydrogen in shipping is still in the demonstration phase. In practice, hydrogen fuel cells have generally been limited to small ships. And one of the main reasons is that compressed hydrogen still has a relatively low energy density compared to fossil fuels. It varies between 10 to 25% for compressed to liquid hydrogen. The largest hydrogen fuel cell fitted on a ship to date is planned for 2023. We're talking about a 3.2 megawatts hydrogen fuel cell. Note the engine size though. Current engines for ocean-going vessels typically vary between 5 to 100 megawatts. 3 megawatts is still below the normal range. Nevertheless, a recent 2020 feasibility modeling study into the China-US route with the current container ship fleet suggests that most ships can be fueled by hydrogen, but they have to give up to 5% of cargo space for hydrogen storage and fuel cells. Other marine engine manufacturers are apparently less convinced about hydrogen. For instance, MAN-ES, which is one of the main manufacturers of two-stroke marine engines, is not expecting hydrogen as a shipping fuel due to what I call technical challenges. And then there's, of course, still the fundamental energy efficiency issue. A recent study shows that about 75 to 80% of renewable electricity is available for propulsion by a battery electric ship, whereas this is 15 to 25% for hydrogen ships. This raises challenges to the scalability of hydrogen as a shipping fuel. So we're in a bit of a pickle here, at least for ships. Electric ships appear to be the best option, but have limited range at this stage. Hydrogen could increase range, but have several issues, including, but not limited to, energy efficiency and technological readiness. So I'd like to end with an expert remark in a 2008 New Scientist article on hydrogen. It was stated that hydrogen has always been the fuel of the future, and it looks like it always will be. I think this is an interesting statement that we can discuss here. In summary, Decarbonizing transport needs to be rapid and deployed at scale. That means that new technologies need to be available and tested, so beyond the demonstration phase, and energy efficient. It appears to me that hydrogen does not meet these criteria, but I'm very interested to hear from the other panel members if they agree.
Thanks so much, Robin. We'll move to Elizabeth. Elizabeth, what are your thoughts on this, and what is your research telling us about the potential of hydrogen in transport applications?
Great. So I think I'm a bit more optimistic on hydrogen than the other panelists so far, at least. So in 2020, last year, the IEA released their Energy Technology Perspectives report that really focused on hard to decarbonize sectors and looking specifically at a sustainable development scenario in line with the Paris Climate Accord. And so I think from the IEA perspective, we see a role for kind of all the possible ways to decarbonize. So looking at electrification, direct electrification, using hydrogen, using biofuels, and using hydrogen-based synthetic fuels. And so looking at these hard to decarbonize sectors, specifically zoning in on transport, this is basically where things are hard to electrify because energy and power density requirements for long distance transport make battery electrification challenging. And so we see three key modes that are going to be hard to decarbonize in time for meeting the sustainable climate goals. And these are aviation, shipping, as mentioned, and heavy duty trucking. And so with aviation, direct use of hydrogen is difficult. Companies like Airbus are actually looking more into that, but we didn't model the direct use of hydrogen, but instead as synthetic fuels, so hydrogen-based synthetic fuels. And we see a large role for hydrogen in the long term there. And so our scenario looked out until 2070, which is the point where we need to meet net zero emissions. And so by 2070, we see 40% of fuel consumption in aviation coming from hydrogen-based synthetic fuels, with the rest coming from biofuels and still some residual petroleum fuel use. For shipping, we also see synthetic fuel use in the form of ammonia because of the higher energy density, as mentioned by Robin. That can be a problem for using the direct use of hydrogen. So we see ammonia being about 50% of shipping fuel by 2070, but we also see some direct hydrogen for some of the smaller vessels at about 15%. And again, we see electrification in that case as well. And then finally, for trucking, I think this one can be a bit more controversial, but we see a role for hydrogen there. And by 2070, we see about 50% of trucks being hydrogen fuel cell trucks. And in our report, you can see we do a TCO analysis that shows that hydrogen trucks tend to have an advantage over about 500, 600 kilometers per day. And so it's really this long haul trucking sector that we see moving to hydrogen. And part of the problem is battery energy density and the loss of payload if you have heavy batteries to go long distances. And we also just see that fast charging may be difficult for heavy duty trucks. And so right now, the current largest fast charger is 350 kilowatts. Tesla is working on a megawatt charger and Daimler as well, but we think this is going to be difficult for the grid. And so I think there are a lot of grid concerns about if we have trucks fully electrified. And so I think from the IEA perspective, we really see benefit in diversifying the fuel supply and going beyond just electricity for this sector. And one of the final kind of non-cost issues too is the resilience and energy security aspect of it. So if all of road transport was electrified, that leaves vulnerabilities to grid failures. And so that's another aspect that we think hydrogen can help approach. And I'll leave it with that.
Thank you, Elizabeth. We'll come back to some observations as well. Justin, as a journalist, you have covered and written quite extensively on energy transition. What did you find about hydrogen?
Well, to answer the initial question, and I think to put this into perspective, I think where Robin was coming from, when I'm talking about this, I'm looking at how do we decarbonize transportation. Of course, hydrogen is being proposed not only for transportation, but also for power generation for, in the UK, they're talking about hydrogen towns where everything will run on hydrogen. I think that's very far-fetched. So right up front, I will say that hydrogen is a distraction if our goal is to decarbonize the transportation system, especially light-duty vehicles. And I think it's very simple to understand. I mean, Robin explained the basic idea, and it comes down to efficiency. And so if you just look at what we're trying to do, because we have, and I believe it was Robin who also mentioned the difference. When we talk about hydrogen, the advertisements we see now are all for green hydrogen. Green hydrogen is less than 1% of the hydrogen consumed. And as Robin said, 99% is based on fossil fuels and produced using fossil fuel power. We're told this is going to be cleaned up with a technology that does not exist right now, which is carbon capture technology. So if we're going to talk about how are we going to decarbonize transportation with hydrogen, it has to be green hydrogen. And so our other option is battery electric vehicles. And the process is we need the renewable energy to power either one of those. So if we have the renewable energy, we can charge electric vehicles and power that transportation. Or we can use it to create hydrogen from water, then compress that hydrogen, then transport that hydrogen, more energy to charge those fuel cells, at which point we create the electricity to power the vehicle. All those additional steps in there take energy and have costs. And so, and that it isn't right now commercially scalable on any level. And the top people who are in the business have said that, people from Siemens who are very big into the hydrogen economy. So right now it's not viable. We do not have time to reach any sort of climate goals to pursue options that aren't viable, but just the energy efficiency that differences. We need renewable energy right now. It's a scarce resource. We're trying to ramp it up as fast as possible. If we can use existing battery electric vehicles and charge them with renewable electricity, which we can, it's commercially viable, it's happening now, that is the solution to pursue. A study that came out this month in the UK looked at decarbonizing transportation in the UK by 2050. And they stated the obvious, that it takes a lot more renewable energy to use hydrogen. But the other thing that they stated was hydrogen being a distraction. If we try to pursue both paths at the same time and make 20% of the fleet based on hydrogen, it again is going to require a lot more electricity. It's a distraction, and it's going to limit our ability to decarbonize transportation. I think Susan did an excellent job of displaying the cost differentials. Hydrogen was by far the most expensive thing. And that's the other thing that's the main barrier. Cost of green, if we're talking green hydrogen. Wood Mackenzie is a consulting firm out of the US. They recently predicted they think green hydrogen will be cost compatible with methane-based hydrogen by 2040. We do not have 2 decades to wait to figure out, and we have to, these things need to be sold to people. They're the cars they're going to be driving. They have to be affordable. Green hydrogen is not going to be an affordable solution potentially until 2040. So we take the efficiency, the cost, it should be off the table, and then just simply the infrastructure. If we look at the United States, if you buy an electric vehicle now, you can charge it in your home, but there are 30,000 public charging options right now across the United States. At the end of last year, there were 46 hydrogen. So, I mean, it's over. Hydrogen has lost. The market has spoken. At the end of 2019, there have been 5 million electrical vehicles sold in the world. As Susan mentioned, you can't get the Toyotas that she used in her example, and they only had sold 7,500 versus 5 million by the end of 2019. Those numbers show, the infrastructure challenges show, hydrogen for light vehicle transport at this point is an attractive idea because it can be clean. It does not work for the economics. It's a distraction from what we need to get done. We do not have time to slow down and think about what ifs. The reality is, the Wall Street Journal this week, a very conservative publication that has been fighting the idea of climate change and climate science for decades, did an analysis and said, if you buy a Tesla now, and I think it was some type of Honda or Toyota, over the course of the lifetime, it's cheaper to own the Tesla. So the economics work right now for battery electric vehicles. You cannot buy a hydrogen vehicle right now if you want it. And in the United States, I've driven across a large part of it. I've never seen a hydrogen fueling station. That's a huge additional cost building out the infrastructure. I agree with the other panelists. If you need to move heavy things long distances over water, potentially through the air and over land, hydrogen has advantages because of the weight it would require for batteries with the existing technologies. There certainly are places where hydrogen can help decarbonize transportation. It has no business being in the discussion about light duty transport, the fleet. And the other thing where the US, thankfully all countries don't have this problem. The US has a massive military. I believe as an organization, it's the largest carbon emitter in the world. To decarbonize the military is going to require hydrogen because the military has very unique transportation options where sometimes size and weight are limited and batteries can be difficult there. There are people looking at this now, but I do believe that hydrogen, we need to deal with the US military emissions if we're going to address climate change. But I think I'll wrap up with a final point is, why are we talking about hydrogen so much? The oil and gas industry has hired very professional public relations people to sell the public on the idea of green hydrogen. Meanwhile, we all know that 99% of it, or we should know that 99% of it is made from methane. The oil and gas industry has made a very large bet on natural gas as a bridge fuel. Natural gas is methane. Now they're trying to convince the public, hey, for the next couple of decades, until we figure out this green hydrogen thing, why don't you use our methane to produce hydrogen? It's not clean, it's not a climate solution, and it locks us into another, methane emissions are a huge issue right now. So this is being pushed as a solution by people who want to sell a lot of methane into hydrogen production.
Thank you, Justin. I would like to go back to a point to all the panelists, and particularly actually to Susan. The question about hydrogen for freight and long-haul distances. Susan, a couple of weeks back, you wrote a piece for The Conversation on this topic, in which you argued that for New Zealand, for example, the country is better off investing in smart rail instead. Can you elaborate on that?
All right. Well, I think I agree with a lot of stuff here. Hydrogen is a great distraction. In fact, I got distracted for years back in the early 2000s on hydrogen. Spent lots of time on that, have patents, have papers. So, you know, I've been around the hydrogen tree, so I know how to do the calculations there of what it can do. About heavy freight. So we've got this hard to decarbonize. Whenever somebody says hard to decarbonize, I say back up that truck, because if what we're trying to do is move bottled water from Fiji to Los Angeles, you can back that up and say, okay, is that actually necessary? If we look at New Zealand and we do the same sort of analysis that I did, where I say, okay, we got to build something, we got to do something. We can move 90% of our essential freight, the stuff that actually has to be moved to a port to be exported into towns, back to the farms, by electric train. All right, electric train's known. We know how to build it. It'll last for a century. You know, your hydrogen kit will last who knows how long, but maybe a few years at the most. The scale isn't there. It's just like, oh my gosh, why would you even be talking about this? We have a lot of work to do getting our capabilities built up just to do electric rail. Think about that. Electric rail is fully known. The engineering is known. The components are known. How long they're going to last is known. The maintenance is known. How to run it. We haven't really done smart rail that much in our little country, but that just means, you know, using the internet. Okay, so just given the monumental task of doing what we do know how to do, why would we talk about adding 3 orders of magnitude monument to that and saying, okay, well, let's talk about that? No. It's time to get undistracted and get on to the job.
Very good. Thank you. I received a question privately, and I encourage everyone to drop them in the chat as well. This is a question to all the panelists, I suppose. If we have green if we have hydrogen vehicles soon, we don't need to provide the extensive electric vehicle charging infrastructure for long distance travel. Hydrogen fuel cells have greater energy density than batteries, and therefore provide greater range to a vehicle. Hydrogen fuel cells are also lighter than batteries, which means that hydrogen vehicles can manage a higher payload. So why not hydrogen vehicles? Anyone would like to address the range issue?
So
I think, go ahead, Elizabeth.
All right, I was just going to say, I mean, I think the range issue is a big part. So, I mean, I think for heavy duty trucking in particular, range is the whole reason why I see a role for hydrogen and that batteries are at a disadvantage. The other reason is the time it takes to refuel or recharge. So if you're using a battery truck, you're going to spend even fast charging. It might still take 30 minutes, where hydrogen can fuel like diesel in about 5-10 minutes. And so I think for heavy duty truck, distance is a main point. I think for light duty vehicles, I have to kind of agree with the others that electrification probably makes more sense for light duty vehicles. But at the same time, on a TCO basis, I think electricity wins out. But at the same time, I think individual consumers are a little less sensitive to total cost of ownership than fleet owners. And I think people have this kind of range anxiety, right? And so even if they rarely go over, say, 200 miles, they want the ability to do that. And so I think that's another reason a mix is nice, because, you know, right now you could say, well, we'd have one electric vehicle for the household and one, you know, normal ICE vehicle. But in the future, the problem is getting rid of that last 10% of the petroleum consumption, right? So how are we going to totally decarbonize without hydrogen? I just don't think we have the battery manufacturing capacity. We haven't set up supply chains for that. I think the grid infrastructure, I mean, hydrogen infrastructure will of course cost a lot, but so are the grid upgrades. I mean, this isn't going to be a cheap transition. It's just figuring out where the investment should go. And that's something, yeah, we have a net zero 2050 report coming out that will talk about investment costs for different pathways. So be on the lookout for that as well. Sorry, Justin.
We'll do, thank you. Robin, did you want to add to the range issue?
Yeah, I think the range issue always puzzled me a little bit, because there have been options like battery swapping as to address those range issues with electric vehicles. So I fully acknowledge the issue with heavy duty vehicles. Passenger vehicles are much easier to electrify than heavy duties. But there was a bit of information coming out about battery swapping, and I think it definitely has potential for fleets like taxi or short haul trucking. Because when you have a battery swapping infrastructure in place, that could potentially lead to very quick refueling, which is very important for trucks. So my understanding is that in China, there's currently 550 battery swapping stations, and it already dwarfs the hydrogen refueling network, which has 96 hydrogen refueling stations. And I think there's a project in the EU called eHaul, where the goal is to develop an automated battery exchange station for heavy trucks, really heavy trucks. So I think there's some unexplored innovation there that we should definitely be looking into. It might also be the most cost-effective solution here.
Thank you so much, Robin. Simone and Paul, I do have a few more questions from online, but I wondered if the audience in attendance in Melbourne's CBD also if there are any questions.
Okay, thanks, Hussein. So does anyone have a question? Wonderful.
Hi, thanks very much for that rundown. I just had a question going back to aviation with that kind of industry set to growth. And it's interesting to seeing the scale up from car, truck and upwards. What has been the link that you've been able to find in terms of that growth, in terms of its future into carbon credits, carbon meeting climate change, and also that hydrogen argument, given that that's what they're trying to push presently?
Elizabeth, would you like to take that one?
Sure. So I do want to say, kind of to Susan's point earlier about the kind of avoid and shift mindset. For our scenarios for sustainable development, we do expect there to be, I guess, less of an increase in aviation traffic than we would normally expect in kind of the stated policies or baseline scenario. And we do look for opportunities where high-speed rail could take certain flight segments. In terms of credits and offsets, I think that's something the aviation industry is looking at now, but the current method using kind of out-of-sector emission offsets is something we don't see as addressing the problem in the long term. And so it's really looking at what fuels we can use in the long term.
Is there another question? Someone else? Yes.
Thanks, Simone. I've heard there's substantial investments going on in Germany into a hydrogen steelworks, and there will not be there'll be many other instances where heavy industry, which is presently using coal as a reducing agent, will shift to hydrogen. And of course, they want ultimately for that to be green hydrogen. Do you think the transport industry could benefit from jumping on the coattails of these heavy industry developments?
All right. Susan, anyone would like to take that one?
I think I want to back up the truck again, because as Robin said, the only thing that matters right now is that next year emissions go down steeply, okay? And so when we look at what is it that we use fossil fuel for, yes, aviation's big and land transport is big. Amongst that land transport, the trucks on roads is by far the biggest. That's the monster. And so by focusing on the hard to decarbonize, the flight or ships, what we're looking at is not doing anything about the monster and talking about the thing that actually is the workhorse of the global economy, but actually the emissions are small. So anytime you feel yourself getting distracted, what it feels like is that you're not talking about the really big thing that needs to move the law, and probably because there's obvious ways to do that. And that means we don't actually start and we don't actually do anything. So
Thank you so much.
Your question exactly, but.
Thank you so much. I'm just conscious we only have 3 minutes to go. Elizabeth, you wanted to say something?
I will just say from the IEA perspective, we do see the need from different sectors such as iron and steel, high industry heating, building heating. We see all of these different sectors that can benefit also from hydrogen or transport leading the way for hydrogen. So in our modeling, we actually see transport as being kind of the biggest hydrogen consumer, and that can help lead the way for these other industrial sectors. But we do think, decarbonizing iron and steel is going to need hydrogen in the long term. And I think from Susan's comment about we need to focus on what to do today, I would argue we need to focus on what we're going to do in the future just as much. I think there are low-hanging fruit in terms of electrifying today, but looking forward, I mean, we can't just stop with electrification.
Thank you. So we have 2 minutes. I'd like to give each panelist a 1 minute just to wrap up, and I'll do the reverse order. Justin, closing observations?
Yeah, I think just to follow up, I do think that those hard to decarbonize things like industry, hydrogen also has potential there. I think it's important though, when we're talking about these issues, to realize that we are being bombarded. Just the reason I started writing about this topic, I've been writing about the energy transition and energy markets for the last 7 years. About 6-9 months ago, I started saying to my editors, someone's coordinating an effort to push hydrogen in the media, because there's no way all of these articles are just appearing. Because this is what I do for a living. I research energy markets, and I knew nothing about hydrogen because it's not being used. Fast forward 6 months, we find out the oil industry's favorite PR agency, FTI, has been funded by the industries and has been pushing hydrogen. So we need to be aware that, and that is all, as I stated before, this is about There is too much methane in the world right now, thanks to fracking that has released all of this methane. They're losing money trying to sell natural gas. Countries like the US and Australia who bet on exports of LNG are finding that wasn't a good bet. Again, I cite the Wall Street Journal again because they're very conservative on these issues. This weekend, they wrote an article saying, oil and gas industry bets future on bridge fuel of natural gas. Looks like it was a bad bet. And so that's in the, I've been saying this for 2 years, but it's in the Wall Street Journal. They have too much methane. They're not making money on it now. And they see hydrogen as a way to tell the public, we're helping solve the problem. The American Petroleum Institute came out this week and said, we finally believe in climate change. What is our solution? Carbon capture and hydrogen. If the American Petroleum Institute is telling you they want to solve climate change and they're proposing a solution, all it means is that's a way, carbon taxes being another one, to extend the use of fossil fuels. And methane is what they have too much of. 99% of hydrogen is made from methane. That's why we're seeing this hype. And I think that's why we need to be very careful that we don't follow these false hopes when we have technology. Solar energy is the cheapest way to produce energy now in most parts of the world. Use solar and wind to charge battery electric vehicles, and we've decarbonized light vehicle transportation. We know how to do it.
Thank you. Closing observations from Elizabeth.
Hi, yes. So I think in terms of using solar and wind, I fully agree, but solar and wind only happen in certain times of the day. So you're going to need energy storage. And there are companies looking at using hydrogen for that energy storage. And in that case, the kind of efficiency argument is moot because you're already losing the efficiency to convert to hydrogen. So I think there's no problem in then using that hydrogen directly in fuel cell vehicles or for other transport. I think there's a lot of going on in the hydrogen world right now. There's a lot of projects coming online, and I'm not going to say that hydrogen is the future, but I think in the next 5-10 years, we'll see how it plays out. So I guess I'll use this as my last plug for IEA publications, and we're doing a global hydrogen review, tracking hydrogen progress and how that's helping meet country targets. And that will be out in September, and it'll be an annual publication where you can start following along with the hydrogen news.
Thank you, Elizabeth. Robin, closing observations?
Yeah, I would just say keep the eye on the goal here, which is rapid reduction in greenhouse gas emissions. There's strong growth in transport use anticipated for all sectors. So we have not only have to reduce the fleet average emission factors, but also the growth. I think the point of critically reviewing how we use transport, what Susan said, is important. But I do think that energy efficiency is a keyword here that is overlooked, and I really want to emphasize that we need to keep that in mind.
Thank you, Robin. And Susan, closing observations.
All right, it's time to open the valve safely, slowly. Come back down to earth, let some of the hydrogen out, bring the balloon back down, get on the ground, and look at real things in real places where you really are, that you're going to do to reduce the amount of fossil fuel that your city, that your company buys next year by 10%. Just do that.
Thank you so much. This brings us to the end of this session. Thank you everyone for joining us today. Special thanks to Simone and Paul on the ground for facilitating this. And thank you to our panelists for their time and for their willingness to share their time, knowledge, and insights. Take care, everyone, and stay safe. And back to you, Simone and Paul.